Welcome to the edge of the impossible. Imagine a world so old, it watched the birth of the galaxy, and so colossal, it dwarfs even the mighty Jupiter. Tonight, we investigate the planet that redefined dominance. Its name is Lipperhey. It sits 41 light-years away, tucked inside the faint constellation Cancri. That sounds impossibly far. But in cosmic terms, this ancient world is practically our closest galactic neighbor. The star it orbits is called 55 Cancri. It glows brighter than almost every surrounding star in that dim patch of sky. You can actually spot it on a clear night. Lipperhey itself, however, stays completely invisible. Even a powerful backyard telescope cannot reveal it. The planet drowns completely inside its host star's overwhelming, blinding glare. Finding Lipperhey required a completely different approach. Astronomers had to watch the star itself move. Lipperhey's gravity pulls its parent star into a slow, measurable drift. Scientists call this radial velocity displacement. It is extraordinarily subtle, but it is detectable if you watch patiently enough and long enough. And patient they were, for nearly 14 full years. Astronomers collected observation after careful observation, building the picture piece by piece. That long, slow process is called an orbital confirmation baseline. It is how certainty is earned. But not everyone was convinced during those years. Several scientists argued the signal was just a stellar activity cycle. They believed the star itself was breathing irregularly, mimicking a planet that simply wasn't there. The data, however, held firm year after year. Every new observation strengthened the case for a real, massive, orbiting world. When final confirmation arrived in 2002, the debate closed permanently. Lipperhey was undeniably real. That confirmation mattered enormously for planetary science. Before Lipperhey, every discovered gas giant was roasting dangerously close to its host star. Nobody had confirmed one sitting calmly at a distant, Jupiter-like orbital range. Lipperhey shattered that assumption completely and permanently. It proved that stable, circular, distant orbits were entirely possible for massive gas giants. Our own solar system suddenly felt far less like a beautiful cosmic accident. And Lipperhey did not arrive in that system alone. It is the outermost member of a confirmed five-planet family. It was among the very first systems discovered holding that many orbiting worlds together simultaneously. Lipperhey dominates that five-planet family completely and absolutely. It carries more mass than all four of its planetary siblings combined. That kind of gravitational dominance is rare. It makes Lipperhey the undisputed ruler of its entire neighborhood. That dominance creates a serious problem for astronomers. Its gravitational pull on the parent star is so overwhelmingly loud, it drowns out the quieter signals of the smaller inner planets. They become almost impossible to measure precisely. Think of it like a gravitational monopoly. Lipperhey pulls so insistently, so continuously, that its siblings disappear inside the noise it generates. The biggest voice in the room makes it hard to hear anyone else. But here is the beautiful contradiction hiding inside that dominance. That same immense gravity also acts as a powerful stabilizing anchor for the entire system. It herds the inner planets, keeping their orbits from slowly unraveling. A bully and a protector existing simultaneously inside one planet. The very force that hides its siblings is the identical force that shields and preserves them. That contradiction is worth sitting with quietly tonight. There is also something unusual about how Lipperhey orbits compared to its siblings. Evidence suggests it moves at a slight tilt relative to the inner planetary plane. The inner system forms a flat disk. Lipperhey circles independently above and below. And unlike most known exoplanets, its orbit is nearly a geometrically perfect circle. Most distant planets swing wildly, chaotically, in stretched elliptical paths. Lipperhey moves with the calm, unhurried steadiness of something genuinely ancient and unbothered. That circular orbit means Lipperhey experiences virtually no seasonal change whatsoever. No dramatic temperature swings, no violent atmospheric shifts driven by distance from its star. It exists in a state of permanent, unbroken orbital equilibrium. Its orbital period is roughly 14 Earth years long. One complete Lipperhey year equals an entire human childhood from birth to high school. A child born today would barely reach graduation before this planet finishes one single lap. And in those 14 years, so much has changed here on Earth. Governments rise and fall. Technologies transform entire civilizations. Yet Lipperhey continues its slow, perfect, indifferent circle, completely unchanged and entirely unbothered by any of it. Now consider the star Lipperhey calls home. Designated 55 Cancri, it carries far more heavy elements than our own Sun ever naturally produced. Scientists describe it as supermetal rich. That unusual abundance changes everything about this system. Among those heavy elements sits a significant concentration of carbon. Under the right conditions, carbon doesn't simply stay carbon. It compresses, crystallizes, and transforms into something far more extraordinary than ordinary planetary rock ever becomes. Some researchers believe that carbon abundance could theoretically seed diamond formation deep inside nearby rocky bodies. Lipperhey quietly orbits a star that may literally manufacture diamonds within its own planetary neighborhood. That thought alone deserves a long pause. But that star carries another secret entirely. A small, dim red dwarf called 55 Cancri b lurks far out in the system. It is a permanent, distant companion to the star Lipperhey has orbited for 8 billion years. From Lipperhey, that red dwarf would appear as a faint second sun hanging in the distance. It would never fully set alongside the primary star. Two suns, two different colors, painting the sky in permanent, unsettling contrast. Now imagine standing on a moon orbiting Lipperhey itself. Above you hangs a massive pale yellow gas giant, filling a significant portion of your sky. Below, the distant primary star glows small and warm on the horizon. That view would feel eerily, disturbingly familiar. A banded giant overhead, a distant warm star below, a faint red companion somewhere in between. It would mirror our own solar system like a slightly distorted, ancient reflection. And Lipperhey's cloud bands may look nothing like Jupiter's familiar muted browns. Its different atmospheric chemistry could produce clouds of pale blue, brilliant white water ice, or deep yellowish gray. We genuinely do not know which. We cannot confirm any of this visually, because Lipperhey never transits its star from our viewing angle. Its atmosphere remains a completely sealed, impenetrable chemical mystery to every scientific instrument humanity currently possesses and operates. It refuses to cross its star's face for us to measure through spectroscopic transmission analysis. It simply orbits, invisible and silent, withholding its atmospheric fingerprint entirely. Some worlds reveal themselves slowly. Lipperhey has chosen not to reveal itself at all. And yet, despite all this invisibility, Lipperhey almost wasn't recognized as a planet at all. Its signal was dismissed, debated, and very nearly buried beneath layers of scientific skepticism. Some worlds have to fight simply to be believed. Even its name carries a hidden wound from history. For over a century, textbooks spelled Hans Lipperhey's name incorrectly. A single misplaced letter, fossilized inside a careless 19th century printing error, followed his legacy for generations. The planet's originally submitted name inherited that exact same typo. It took the International Astronomical Union until 2016 to officially correct the spelling. One small letter, one enormous difference in honoring a man's true historical identity. Hans Lipperhey applied for the very first telescope patent in recorded human history. The planet now carrying his corrected name was discovered using the precise scientific descendants of that original, world-changing optical instrument he first envisioned. There is something deeply circular about that connection. The tool he first patented eventually grew powerful enough to detect a planet's gravitational wobble across 41 light-years of empty, silent space. That is not a coincidence. That is legacy. So what is Lipperhey truly, at its core? It sits right at the upper boundary of planetary classification, teetering on a razor-thin edge. Just 13 times more massive, and deuterium fusion would ignite inside its core permanently. That fusion would make it a brown dwarf, a failed star, something caught between planet and sun. Lipperhey is not quite massive enough to burn. It exists permanently inside a fascinating, uncomfortable classification borderland between two worlds. Lipperhey is the answer to a question we forgot to ask. It proves that stable, circular, Jupiter-like giants exist far beyond our solar system, anchoring distant families of planets in quiet, unbroken gravitational equilibrium across deep time. If this keeps you awake tonight, subscribe to the Sleep Lab, because there are countless worlds still waiting to be investigated just like this one. Lipperhey has orbited in perfect silence for 8 billion years. We are only just beginning to listen.